Hi, this is Algebra 1, Lesson 76. We're going to talk about consecutive integers, and we're starting on page 313. If we use n to designate an integer, and then look at a number line, we can see that the integer to the right of any given integer, so if we have -2, the integer to the right is -1. The integer to the right of any given integer is always 1 greater. If we have 0, then the integer to the right is 1. If we have 1, then the integer to the right is 2. It's always 1 greater. So if we're starting with n, the next integer is n plus 1. And the next greater one is n plus 2, etc., etc. Integers that are 1 unit apart are called consecutive integers. So here's an example. Find 3 consecutive integers such that the sum of the first and the third is 146. First, we start by naming the integers. So we have 3 consecutive integers. So we'll start with n. The next integer will be n plus 1. And the third integer will be n plus 2. The sum of the first and the third is 146. So n plus 2 equals 146. Now, to find what all these numbers are, we can solve for n. So n plus n is 2n plus 2. Remember, this is adding. We're not going to multiply through. We're just going to add, which equals 146. Get the n's by themselves by subtracting by 2. And 2n equals 144. Divide by 2. And n equals 72. If n equals 72, then n plus 1 equals 73, and n plus 2 equals 74. We can check this by seeing if n plus n plus 2 equals 146. So 72 plus 74 is indeed 146. Okay? Alright, here's the next one. Find 3 consecutive integers such that twice the sum of the first two is 2 less than 3 times the third. So we went from a pretty easy one to a pretty complicated one. Alright, so we're going to start by naming the integers. So we have n plus 1, and n plus 2. Twice the sum of the first two, so 2 times the sum of n plus 1, is 2 less than 3 times the third. So if we add 2 to this side, it's going to equal 3 times the third integer, which is n plus 2. Okay, so that's our equation. And now we're going to solve for n. So we have 2 times n plus 1 plus 2, which equals 3n plus 6. I am writing way too big. We have 4n plus 2 equals 3n plus 6. This is 4n plus 4 equals 3n plus 6. I'm going to move this up here. Let's subtract both sides from 4 and subtract both sides by 3n to get all the n's on one side. So 4n minus 3n is just n, and 6 minus 4 is 2. So n equals 2. That was nice. So n plus 1 equals 3, and n plus 2 equals 4. Let's check this. n plus 1 is 5, times 2 is 10, plus 2 is 12, And that should equal 3 times n plus 2, which is 4. So that's 12. 12 equals 12, so that's true. Okay, let's try this one. Find 4 consecutive integers. So we have 4 integers this time. So we have n plus 1, n plus 2, and n plus 3, such that 6 times the sum of the first and fourth is 26 less than 10 times the third. Okay, so we have the sum of the first and fourth. That's n plus 3. And we want 6 times that. Is 26 less, so we're going to add 26 to this side, and that way it will equal 10 times n plus 2. Alright, let's clean this mess up. We have 6 times 2n plus 3 plus 26 equals 10n plus 20. This is 12n plus 18 plus 26 equals 10n plus 20. So this is 12n plus 18 plus 26 is 44 equals 10n plus 20. Okay, let's subtract 10n from both sides and subtract 44 from both sides. And we have 2n equals negative 24. We're going to divide by 2, and n equals negative 12. If n equals negative 12, then n plus 1 is negative 11. N plus 2 is negative 10. And n plus 3 is negative 9. So let's check. 6 times negative 12 plus negative 10, which is negative 22. So 6 times negative 22. Let's see, 22 times 6 is 132 plus 26. That's not right. What did I do? Oh, I did the wrong one. Alright, 12. Alright, so negative 12 plus negative 9 is negative 21 times 6 is 126. It's negative 126. Plus 26 is 100. So that's negative 100 on this side equals 10 times n plus 2, which is negative 10. So this is negative 100 equals negative 100. And that's true. And that's it for this lesson. Try your practice problems. Let me know if you have any questions. Be careful setting up the equations. That's always the tricky part. Do the practice problems and try all the problems from this chapter. Thank you very much. Bye.